Hello, Algebra 2 students, and welcome to Lesson 3.3. We're going to look at a few different types of factoring. Okay, a lot of this is review, but it's going to be problems that look a lot more complicated than what you've seen in the past. So our difference of squares, remember a squared minus b squared is a plus b, a minus b. So if we have something that looks like this, we're going to take the square root of each term. So the square root of 25x squared is 5x. The square root of 36y squared is 6y. And then we can factor it as shown. The square of a sum. So here we're taking a binomial and we're squaring it. Remember, this is the shortcut method. This is a good thing to learn. Any time you can learn a shortcut in mathematics, it's going to help you out in the long run. So we take the square of the first term, the square of the last term, and in the middle, it's twice their product. Remember, if this had been a difference, a minus b squared, then this term would be a difference as well. So we'd have a squared minus 2ab plus b squared. The difference of cubes. This is a little more complicated. We have two parts. We have a binomial and a trinomial. The binomial is made up of the cube roots of each term. Okay, the cube root of a cubed is a, cube root of b cubed is b. Then this trinomial comes from squaring the first term of the binomial and the last term of the binomial, but this time the middle term is just ab, not 2ab. You'll notice these two trinomials are very similar, except that that middle term is ab. So if it's a sum of cubes, you're going to see a very similar pattern. The only difference is the change in the signs. Notice how this sign is always the same as the original. This sign is always opposite. This last term is always positive. So we use SOAP as a way to remember that pattern. Same, opposite, and again, same meaning same as the original. Opposite of the original, always positive. So if we do something more complicated, like 8m cubed minus 27, we take the cube root of 8m cubed is 2m. The cube root of 27 is 3. And then we get the next term, again, by squaring these two. Squaring the 2m, squaring the 3. And then in the middle is their product, 2m times 3. Remember that 2 is from the 2m. Okay, it's just ab in the middle, but a in this case happens to be 2m. The next example, we've got g cubed plus 64 h cubed. The cube root of g cubed is g. The cube root of 64h cubed is 4h. So that's our binomial, again with the sum now because this is a sum. The trinomial, we square g, we square the 4h at the other end, and in the middle it's their product. So minus, because this was a plus, g times 4h. So that becomes minus 4gh in the middle. Okay, so let's try some other examples. So how can we prove this identity? We can prove this is the factorization of the sum of cubes. And we can prove it just by using what we did in the last section and multiplying this out. So I'm going to distribute the a over all three terms. So I get a cubed minus a squared b plus ab squared. Distributing the b, I get a squared b. I'm going to line that up vertically. B times the middle term is minus ab squared, and b times b squared is b cubed. So you can see my middle terms are opposites, so they're both going to drop out, and I'm just left with a cubed plus b cubed, which is exactly what I have here. So how can we use the identities to multiply this expression? So here again, we're squaring the binomial. So let's use the shortcut. So remember, it's the first term squared. Actually, I'm going to take out that first parenthesis. We don't need that there. The last term squared. And then the middle is 2 times their product. That's a plus. So when I square 2x, I get 4x squared. 2 times 2 in the middle gives me a 4xy cubed. Oh, and that should be, sorry, that should be a square. So it's 4x squared y cubed. And then when we take y cubed and multiply it by itself, remember y cubed times y cubed, we're adding the exponents, so it becomes y to the 6th power. Okay, now, oh, and I missed the square here. Sorry about that. I just did a 2x instead of a 2x squared. Let me rewrite this. Okay, so the first term, 2x squared, and we're squaring it. Let me spread this out. Plus 2x squared 2 times 2x squared times y cubed, and then it's plus y cubed. I should have just erased the whole thing from the beginning. Y cubed squared. Remember the pattern, we're using the a plus b squared. We square the first, we square the last, and in the middle it's 2ab. Okay, so I'm squaring the first, squaring the last 2 times the product of a and b. So back to this, 2x squared squared is 4x to the 4th power. X squared times x squared is x to the 4th. And let me just double check, 2 times 2, good, good. So there's our expansion. Okay, example 3. Now we're going to do some factoring. So for factoring, you're going to have to look at these and recognize now, are these squares or cubes? Okay, 9 and 25, those are perfect squares. So I'm going to use my a plus b, a minus b pattern to factor this. So I'm taking the square root of each term. Square root of 9m to the 4th is 3m squared. The square root of 25n to the 6th is 5n cubed. And remember, you can always check these by multiplying them back out. Okay, make sure you end up with what you started, how the problem started. Okay. For the sum of cubes. Okay, so remember our pattern, when it's a cubed minus b cubed, we're going to have a minus b. And then for the trinomial, we square a. Then there's no 2. This is just a plus ab. Okay, and remember we get those signs from SOAP. Same, opposite, always positive. So here the cube root of x cubed is just x. The cube root of 216, I believe, is 36. Let's double check. 216 cube. Oh, 6. What did I say? I was thinking 36 times 6, so it's 6. Okay, so that's the binomial part. Now for the trinomial, I look at this, I square x. In the middle is plus their product, so plus 6x, and then the last term is the 6 squared. And again, you could check this by distributing and make sure you go back to the x cubed minus 216. Okay, so that's the 3 different types for our lesson. So the difference of squares, the sum, or the square of a sum, and then the difference of cubes and the sum of cubes. These are the 3 patterns that you want to focus on, and we'll do more practice in class. Okay, so I hope you enjoyed the lesson and have a good day.